there's this app called
notebooklm.
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 The notebooklm.
to notebooklm.google.
You can convert your study notes, study outlines, whatever, into a conversation between two people, like a podcast, and listen to that instead of study it by yourself. Crazy.
It's amazing. But it's made by Google, a company that's notorious for killing projects. So much so that there's even a website dedicated to listing all the killed projects. I, for one, like predictability. It would suck to be reliant on an app one day just for it to no longer exist the next. So what's the solution? Well, building my own version. To start, we need to understand how notebooklm works. So here's a quick run through. You upload sources and it generates content based on those sources.
Welcome back for another deep dive. Today, we're going to try to tackle Lagrangian and Hamiltonian mechanics.
That's all the end user sees. Honestly feels like magic. And now I'm tasked with the job of figuring out the trick. So going through this process, I had to think about what Google might be doing behind the scenes. Here's what I got. I'm pretty sure we've all had an experience with an LLM where it wasn't really helpful, or it might have just outright made things up or lied to you. These are referred to as hallucinations. This happens because LLMs know a lot about everything, but they don't know everything about any one thing. They lack specialized context. What does this mean for us in the problem we're trying to solve? Well, we want to study a specific topic. Framing it this way, it doesn't sound like a bad idea to just ask ChatGPT to explain things. But we want to use specific information to study, this being our notes, our lecturer's notes, or a textbook. ChatGPT doesn't have any knowledge about these things, so we need to give it the information, thereby enabling it to generate helpful content about the sources. So that's step one. But we want a podcast, which means we still need a script and audio. Since the LLM now has context of our notes, we can just prompt it to generate a script from the information we gave it. And voila, we've got a script. Now, time for audio. I've never worked with audio generation before, so I need to do some research. I think I found the solution. 11 Labs is a name that kept popping up in my research. And after messing around with it, I believe this is the way to go. A concern I had was that the voices might sound robotic, kinda like typical text-to-speech systems or those clearly AI-generated YouTube shorts.
Casinos are actually charity.
But these voices sound good.
You sound good too, baby.
And you can pick from a wide variety of options, even being able to create your own voices. So we're going with 11 Labs for audio generation. At this point, we've got all the pieces we need. Now it's time to put it all together. Here's what I have so far. How it works is you upload a file. Say I'm studying for a mechanics exam, which I actually was not too long ago, so I'll be able to verify if the output is nonsense. So how it works is you upload the file and click submit, and you'll see here just formatted the output, so it kind of steps you through what's happening at each process. So it just created the context that we spoke about, and it's now generating a script and will output it once it's done. There we go. And you can see it's in a dialogue format, right? And the two podcast hosts I have are named Mark and Samantha. I went with two because it feels natural, right? More than two kind of felt messy. So two speakers, and this is the text that they or rather the dialogue that they're having with one another. So it's an entire script, and now after the script is generated, we now generate the audio segments, right? And what's happening here is we generated per dialogue section, right? So for each of these little pieces here, we generate the speech, and that's what's happening here. So Samantha spoke first, Mark speaking, so on and so forth. And we'll just let this process run as well. Cool. And now it just combines all those separate audio segments to finally output the audio. And there we go. And how this works is it's all here still. So I generate a bunch of temporary audio files, and then at the end of the day, I join them together to form this final file. And that's what we see here. So if I click play.
Hey Mark, welcome back. Today we'll be diving into the fascinating world of Lagrangians and Hamiltonians. I just read this book that outlines variational techniques in mechanics. How exciting is that?
Exciting indeed. Lagrangian and Hamiltonian mechanics take a different approach compared to classical Newtonian mechanics, right? Could you maybe shed some light on how they differ?
Absolutely. Essentially, Lagrangian mechanics focuses on the principle of least action, which states that the path taken by a system is the one for which the action integral is minimized. This contrasts with Newton's laws, which deal with forces directly.
Interesting. And Hamiltonian mechanics takes this even further, right? How does it build upon the Lagrangian framework?
Yes, Hamiltonian mechanics reformulates classical mechanics using the Hamiltonian function, which represents the total energy of the system. It provides a powerful framework for analyzing dynamical systems, especially in terms of phase space.
Phase space. Now that's a concept that makes it much easier to visualize how systems evolve over time. So, how do generalized coordinates fit into all of this?
Great question. Generalized coordinates allow us to describe a system's configuration in terms of any set of parameters. They simplify the equations of motion significantly, making it especially useful for complex systems with constraints.
Constraints? Can you dive a little deeper into that? How do they interact with the Lagrangian and Hamiltonian methods?
Sure. Constraints, like holonomic or non-holonomic ones, restrict a system's degrees of freedom. When we incorporate these constraints into the Lagrangian framework, we often use Lagrange multipliers to account for them and derive the equations of motion accordingly.
That sounds quite handy. And I assume these constraints lead to some conservation laws?
Exactly. Noether's theorem beautifully ties symmetries and conservation laws together. For every symmetry related to the system, there's a conserved quantity, be it linear momentum or energy.
It's amazing how all these concepts are interconnected. But can these methods extend beyond mechanics? What about field theory?
Yes, the principles of Lagrangian and Hamiltonian mechanics extend into the realm of field theory, allowing us to describe the dynamics of fields like electromagnetic fields, similarly using varying generalized coordinates.
Wow, it's quite a profound approach to understanding the universe. So, what key insights should our listeners take away from this?
To sum it up, understanding Lagrangians and Hamiltonians provides a robust framework for tackling complex physical systems, especially through the lens of generalized coordinates. Plus, the connection between symmetries and conservation laws is crucial in theoretical physics.
Perfectly said. Thanks for sharing, Samantha. The world of analytical mechanics is indeed captivating. Until next time.
Until next time, Mark, keep questioning and exploring.
Sounds good to me. Alright, so currently it just generates a podcast using the entire PDF. But I think it would be cool if you could specify what you want the podcast to be about. So instead of deep dives like what notebooklm does, this could be a bit more bite-sized content, which I honestly think is better because real learning happens when you acquire bits of related information and are able to form an overall understanding of a topic. Long-form deep dives provide a complete picture up front, limiting the chance to develop your own perspective. In contrast, shorter, focused episodes let you build a bigger picture independently, thereby deepening your understanding. So, that's what I'm going to work on now. I never seem to feel as comfortable working on the back-end aspects of my projects as I do on the front end. The reason is simple. I spend more time working on the front than I do in the back.
What did he say?
There's probably a joke to be made here, but I can't think of one now. I just seem to enjoy the immediacy of seeing a visual representation of what I'm working on and interacting with it. But I'm getting to the point where I feel like I should invest a good amount of time in getting good at back-end stuff, solely because of the fact that it bothers me how uncomfortable I feel there. But I'm not entirely sure of how to go about it. There are obviously plenty of resources, roadmaps, and so on that I can use, so I'm most certainly exaggerating a non-issue, and I'll resolve it. Another tangentially related lesson I seem to keep having to relearn is to read the documentation. I know the edit made things seem smooth, but man, I struggled. All because I thought I knew what I was doing, but rarely is that ever the case. So read the documentation. Surprise, surprise, it actually helps. And well, it does also help that 11 Labs has pretty slick documentation. Alright, so now you can explicitly state what you want to learn about. This is cool, but the app looks ugly. Time to make it look pretty. Just like you, my 100% male audience. Okay, so this is what we've got. It's inspired by the notebooklm and Apple Podcast UI. Here's how it works. Podcasts are grouped in playlists. For example, say I have a mechanics exam coming up, keeping with the same theme. I create a playlist for mechanics related content by uploading all the sources which I want to use to study, in this case being textbooks and the lecturer's notes. Now I can create podcast episodes about any concept from the sources I uploaded, and they will all be stored in this mechanics playlist. I experimented with other ways of organizing content, and this approach came out as the best. Let's give it a full test. Click create playlist, upload the sources, and it should... Okay. Certainly unexpected. I promise this doesn't usually happen to me. Liar! Give me a sec. Alright, let's give that another go. Create playlist, upload sources, 1, 2. And now the same process that we've seen before is happening here where it gets the context. So I'll just speed through this part. Ignore those. Okay, so now it took us to the playlists page. This is where all content regarding mechanics podcasts will be posted. So if I were to go back, our page now looks like this, and you can imagine if I had multiple playlists, they'd all be shown here. So let me just quickly rename this rather to mechanics, and I come back in here. Okay, so these are the sources that I uploaded, right? The 2 textbooks. You can view them just to make sure that everything's working correctly. Cool. And now to generate a podcast, the process is still the same. Let's say I wanted to learn about a concept called cyclic coordinates. This has to do with how Lagrangian mechanics works. So I create a new podcast titled Cyclic Coordinates. and I give it the instructions to generate a podcast about cyclic coordinates. Click create, and again, we're familiar with this process now, so I'll just speed through this. Great. So now we have a podcast generated about cyclic coordinates, and if I hit play, it fetches it from S3, shows it up here.
Hey everyone! Welcome back to our podcast. Today we're diving into the fascinating world of cyclic coordinates in physics. Mark, are you ready to unravel this topic?
Absolutely. Cyclic coordinates are super interesting.
Alright, we get the point, right? But you can see how you can manipulate it. It feels very natural. See the outro?
And that's a wrap for today's discussion on cyclic coordinates.
Thanks for listening, everyone. Until next time, keep questioning the universe.
Keep questioning the universe indeed, Samantha. Alright, so this is pretty cool. I mean, it looks nice as well. I would have loved to make the hosted project available to all of you for use, but yeah, these 11 Labs credits are not cheap. Link to the GitHub is in the description though, so if you want to check it out, well, you know where to find it. The irony of working on this project is I could have used the time spent working on it to study, but honestly, I wasn't working on this project to help me study. It was more so for my own sanity because, well, studying computer science has been a bit of a disenchanting experience. I won't really get into that here because that's not what this video is about. If that's something you would like to hear though, just let me know and I'll get to it. If you made it this far, consider subscribing, like the video, and thank you for your time.